Hello, everyone. Let's get started with today's lesson, where we'll explore how to rotate a shape on the coordinate plane around the origin. First, let's quickly review the coordinate plane. It's made up of two perpendicular number lines, the horizontal x-axis and the vertical y-axis. They cross at a point called the origin, which is at 0, 0. Every point on the plane is described by an ordered pair, x and y, which tells us its horizontal and vertical position. On the x-axis, numbers increase as you move to the right and decrease as you move to the left. So, points to the right of the origin have positive x-coordinates, and points to the left have negative x-coordinates. On the y-axis, numbers increase as you go upward and decrease as you go downward. That means points above the origin have positive y-coordinates, and points below have negative y-coordinates. The coordinate plane is divided into 4 sections called quadrants. They are numbered counter-clockwise, starting from the upper right section. Each quadrant has a different combination of positive and negative values for x and y, which helps us understand where a point is located. Now, let's look at our problem. We have a triangle with vertices at point A at -4, 0, point B at -5, -3, and point C at -3, -5. Our task is to rotate this triangle 90 degrees counterclockwise around the origin and find the new coordinates of its vertices. When we rotate a shape around the origin, each vertex moves along a circular path centered at the origin. The shape itself keeps the same size and shape, it's congruent, but its orientation changes. There's a helpful rule for a 90-degree counterclockwise rotation. Any point x, y moves to a new point, -y, x. It's useful to think about why this works, but for now, we can apply this rule to each vertex of our triangle. Let's apply the rule. For point A, which is at -4, 0, after rotation it becomes 0, -4. For point B at -5, -3, it becomes 3, -5. And for point C at -3, -5, it becomes 5, -3. So, the new vertices of the triangle after rotation are A' at 0, -4, B' at 3, -5, and C' at 5, -3. If we were to look at a diagram, we would see the original triangle in blue and the rotated one in orange. Each vertex has moved along a circular path around the origin. The key idea to remember is that rotating a figure around the origin means we rotate every vertex by the same angle. So, understanding how a single point transforms under rotation allows us to rotate any shape on the coordinate plane. That's all for today. I hope this helps clarify how rotation works on the coordinate plane. See you next time.